All right, guys, so I'd like to tell you about this idea called a Fermi problem and where we're going to go with this. This man right here is Enrico Fermi. He was a really famous physicist in the 30s and 40s. He did a lot of early work on the atomic bomb and stuff, but what he was famous for was taking a problem that at first glance really didn't seem possible to solve, right? And his classic example was guessing how many piano tuners there were in Chicago, given only the number of people that lived there. Sometimes these are known as back-of-the-envelope questions or order of magnitude estimations. And this is a super useful tool. Arguably, the ability to set up and solve Fermi problems is the most important thing I'm going to teach you this year. And it's really just a glorified form of unit conversion. This is the secret physics karate that I mentioned about. And I just want to kind of review for a second how it is that this unit conversion works. So you're going to take some starting value, which is a known thing. This could be your height. This could be, the length of the object whose length you're trying to convert. This could be a weight. This is something that you know. And you're going to multiply it by a fact, or maybe two, or three. But a fact is something that is always going to be true for everyone, everywhere. For example, it is a fact that 2.54 centimeters is equal to 1 inch. That is true for every single person on the planet. That is true where you go. You cannot change that. Something that might seem like a fact is something like, well, right now I'm 14 years old. Well, right now you are, but the person next to you isn't, and you won't be from, like 8 years from now. We'll get into that later. But a fact is something that is always going to be true. And the big idea here is that if you take a known fact and you combine it with multiplication with another fact, the answer also has to be a fact. So when we did our height conversions earlier this week, and I just used mine for an example, a height of 73 inches, that's a starting value. I'm going to take that known for sure value and I'm going to multiply it by the fact that 2.54 centimeters is equal to 1 inch. And when I write the fact in the correct form of having inches on the bottom, this inch canceled and that inch canceled. And now it leaves me with only units of centimeters. And when I multiply 73 times 2.54, I get 185 centimeters. Here's the huge idea. If that's a fact and that's a fact, then this has to be a fact. And the units prove it. Because if the units cancel out, that means you set this thing up right. Sometimes you're going to chain together more than one fact. You might have 2 or 3 or 5 or 20. And we saw this last time on the notes where I think I converted ounces into kilograms by having to convert first into pounds and then pounds into kilograms. That was from last time's video. We're going to see something much more complicated than that later. But the big idea is, as long as all of the things that you are combining together are facts, then the final product over here, the answer you get, has to be true if all of the inputs are true. And so if I did something like converting 10 meters per second into miles per hour, well, I just have two conversions that I'm doing right here. I need the fact that 1 mile is equal to about 1,600 meters, and the fact that an hour is equal to 3,600 seconds. And I'm going to take a quick little shortcut here. There's the first fact that'll convert the distances. Here's the fact that'll convert the times right there. I need to get rid of meters. Meters is on top. And so I'm going to write my fact in the form that I have miles on top and meters on the bottom. And I've got seconds on the bottom right here, and I need to get rid of that and turn it into hours. So to get rid of these seconds on the bottom, I'm going to use the form of this fact that has seconds on the top. So seconds go up here, and hours go on the bottom. I can plug in the numbers later, but right now what I'm going to see is that the meters will cancel the meters, and the seconds will cancel the seconds, leaving me only with miles per hour, which is what I want. So 1 mile is 1,600 meters, and 3,600 seconds is 1 hour. Those are both verifiable facts. You can look this up. That will never, ever change. And so once I've taken the starting value, which I'm assuming to be correct, this is the thing that I'm trying to convert, as long as I'm combining it with these two facts right here, which are not changeable. Those are like set in stone. That will always be true. Then this answer over here has to be right, unless you do something dumb on the calculator. And so I wind up getting, I can do math on here, I think it winds up being about 22.5 miles per hour. I know this is true because of two reasons. First of all, I'm only including facts in my answer, and I know that I've set this up right because I can see that the units wind up canceling each other out, which forces the problem to be correct. So, what if you don't use facts, right? We were 100% sure that this answer was right because we were 100% sure that we were including facts in our problem. But you could use something besides facts as long as you're okay with your answer not being 100% for certain. All right, you could include something in there like a measurement, which is a number that's specific to you or to your problem. You know, the measurement being your height, which can change from time to time, or your age, or the number of times that you do X, Y, Z, or the amount of time since you most recently did whatever. You could also use estimations or estimates, which, you know, you could Google, like, about how many miles is it from Oregon to California. You could call upon past experience. You could use some common sense. If I said something like, hey, what's an average ninth grader's height? You could say, well, probably about, I don't know, more than 5 feet, less than 6 feet, somewhere in there. These won't be facts if you combine measurements and estimations and stuff with a starting value. A fact and a measurement and an estimation will not come out to be a fact, which is 100% true, but, and this is a really powerful tool, they will come out to be a pretty good estimation. How good? Well, how good were your measurements and your estimations that you put in? Businesses do this daily. I mean, this is a huge part of every business, from like multi-billionaire billion-dollar companies like Apple and IBM and Nike and stuff, all the way down to the food cart just down the street. If you ever hear something like, well, experts predict that by the year 2030, Americans will blah, 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 they're doing this process as well. This is also something that comes in really handy if you're planning to build anything or planning a trip or coming up with any sort of plan for or something you want to make or do. And so the example that I'll give you guys here is going to have to do with the number of pizzas I have ever eaten. You can't Google this. Sometimes when I think about Fermi problems, I want you to think of these as being un-Googleable. Because I can ask Siri or Google how many centimeters is 73 inches, and they'll tell me that. If I said, hey Siri, how many pieces of pizza have I ever eaten? Well, let's find out. Hey Siri, how many pieces of pizza have I ever eaten?
I found this on the web.
Yeah, see, that doesn't help me out very much. But this is going to come up with a really nice estimate. I'm going to have a pretty good approximation, assuming that I put in some really good values to start with. And the better my inputs are, the more accurate these are, the more accurate my approximation is going to be. So I'll start by brainstorming out my facts, my measurements, and my estimates about this problem. And you might wind up brainstorming more things that you need. That's okay. I'm just going to start by throwing everything out there, all the facts and measurements and estimates that I can think of that might have anything to do with this problem. So let's see, if I'm talking about how much I've ever eaten, it might be important to know that my age is, well, I'll be 40 next week, so we'll just say 40 years. All right, that seems like a fact, but that could change. Next year, this problem will have a different answer, so this is really going to be more of a measurement. This has to do with me right here. Another thing that I might guess on here is that I eat pizza. Gosh, I'm just going to estimate. I'm going to say I average about 3 slices per week. I'd say I eat pizza once a week, and I usually have about 3 slices at a time. So yeah, that's a pretty good estimate right there. I don't know if that's true or not. I don't think I probably ate a lot of pizza when I was 6 weeks old, but I certainly ate a whole ton of it in college. So that's a pretty good estimate. By the way, it's okay if you're not 100% sure on these. It's okay to just be, you know, as long as they are about right. They don't have to be perfect. That's fine. We're coming up with a good estimate here, not a perfect solution. Finally, I might want to know something related to how many weeks are in a year, and so I know that 1 year is equal to almost exactly 52 weeks. And I really don't want to get into a conversation about leap years or, you know, leap seconds or anything like that. So we're just going to say, yeah, that's a fact. So there's 52 weeks in a year. It so happens that in brainstorming this problem, I wound up with one of each. That's not necessary. You don't need to have one of each. That's not important. You could set up a Fermi problem that happens to have one fact and one measurement, or just 2 estimates. It's fine. It just so happens that I had one of each. You don't need it. So what I'm going to do then is start by brainstorming out all of the things that all of these facts or measurements or errors in fraction form and seeing what winds up being what. So I could write that 40 years equals me, or I could say that I am 40 years. I could say that I'm going to eat 3 slices in 1 week, or I could say in 1 week I'm going to eat 3 slices. And I could say that 1 year is 52 weeks, or I could say 52 weeks is I don't know why I said equals there, 1 year. Now, important thing here, this is or. I'm only going to use one out of these two. You will never, ever, ever use both forms of a fraction in either a simple unit conversion or in a Fermi type problem. So the way that this sets up for me is actually really useful. I want to know number of pizzas per me. I want to know the number of pizzas that I have ever eaten. And so I know that my answer is going to have to end with slices on top, slices, and on the bottom, well, there's not really much of a fraction here. I'm just going to say how many slices am I worth, or how many slices have I ever eaten. And this is going to help me out quite a bit when I look at each of the three forms of these facts right there, because I know that somehow I'm going to have to pick one that has slices on top. Well, if I look through here, of all of these options that I've listed out, I see the only one that has slices on top is that, and so I know I won't be using that form, because you will only ever use one form of the fraction. And so what I like to do is circle and cross it out so it's real obvious which ones I'm using. Second thing is I know that I wind up with me on the bottom, and so I'm going to get rid of the form that doesn't have that. I know I'm going to need to somehow incorporate me being on the bottom of the fraction right there. And so it doesn't really matter which one of these three facts I multiply times each other. You know, A times B is the same thing as B times A. But I'm just going to start with this one because it's on the left-hand side. I'm going to say that 40 years is the same as 1 me. And that's of course going to be a measurement, so I'm not 100%, like that's not perfectly accurate. And I'm going to say that I average about 3 slices a week. Again, an estimate. That's not perfect, but that's a pretty good estimate. 3 slices in 1 week. None of these things yet are canceling out, which means they're not yet going to be equal to slices per me. What I need to do is somehow get rid I want to keep slices, right? Like this is good. I'm going to color code this. Slices needs to stay up here, and let me just go to a different color. Me needs to stay down there. I need to get rid of this years and weeks business. I need to get years off of the top, and I have a fraction over here that lets me do that. I found a fraction that has years on the bottom, and so I'm going to throw that one in there and see what happens now. 52 weeks over 1 year. So if I look at my units now, what I'm going to see is that I have years canceling out, and I have weeks canceling out, and all that leaves me with then is slices over year, which the answer is the units for the answer that I'm trying to find. So I wind up having, or slices per me, sorry, not per year. So I wind up having 40 times 3 times 52 on the top over 1 times 1 times 1. And I can't do that math in my head, but fortunately I have a calculator here, and it winds up being something like 6,240 slices of pizza that I, or me, has ever eaten in my entire life. Is this 100% accurate? Of course not, right? This is not going to be 100% accurate because I didn't have perfect accuracy in these three estimates right here. But if I really needed to know a good approximation, that'd be a pretty good start. The answer to all these Fermi problems, or these ungoogleable problems, we're not looking for a specific answer. We're looking for a really good, scientifically and mathematically based approximation or guess. All right, I'm going to try one more example with you guys, and it goes like this. How much does it cost me, the gas money, how much do I spend on gas to drive to LaSalle in a week? Well, we're going to start by listing out all the different facts that might matter on here. One thing I know is that in 1 week, I drive to LaSalle twice. Mondays, Tuesdays, and Wednesdays, I stay home. Thursdays and Fridays, I go into school. Is that always true every single week of the year? Of course not. This is an estimate right here. Actually, yeah, this is not going to be a fact. This is not always going to be true, but it's a pretty good estimate. The second thing on here I would have to think about, if I'm talking about cost of gas money, is how much a gallon of gas costs. And so I would have to go and look. I have no idea what the price of gas is at the corner of the gas station down the street from my house, but I know it's something like $3. But what if it's $2.89 or what if it's $3.12? I don't care. It's about $3. All right. This is going to be, this is an estimate right here. Estimate, all right, and this is a measurement about myself. I know from past experience, or I know because I've done this enough, that these are not facts, but they're really decent, close guesses. It's not like I'm trying to tell you that gas is $5,000 a gallon, or that in a week I'm going to drive to LaSalle, 1,000 times or anything. These are good guesses. Another thing that I'll have to do and would be to know how far is it to LaSalle, because the mileage, if I only have to drive 1 mile, that's not going to cost very much gas. If I have to drive all the way across the state, that's another one. What I can do now is get on Google. Google's your friend. You're always welcome to Google everything, and map it. And from my house to LaSalle is 11 miles. So since I have to go there and home, one full trip to LaSalle is going to be the same thing as 22 miles. This is, of course, is another measurement. This is not a fact at all. I'm measuring this for on Google Maps. Your mileage will vary. It'll be different for you. You live a different distance away from LaSalle than I do. Finally, the other thing that's going to matter on this is going to be the number of miles that I can drive on 1 gallon. Whether I'm doing this in like some sports car or in a huge truck with terrible fuel efficiency, or like in a little hybrid or something. And I know from past experience that the little Honda that I drive to LaSalle and back gets about 25 miles to the gallon. So what I know is that when I drive in the city like that, 25 miles is the same thing as 1 gallon. And this is another measurement right here because I have calculated this before. It varies, time of year, time of day, whether I'm going uphill or downhill, if I've got a bunch of heavy stuff in the trunk, whatever. But this is a pretty decent guess for all 4 of these things. So the next step then would be to set out the number of, or the different forms of the fraction. So I could say that 1 week is equal to 2 trips, or I could say that 2 trips is the same as 1 week. I don't really know what the symbol for trips is. How about TR? Sure, sounds good. I could say that 1 gallon of gas is the same thing as $3, or I could say that $3 is the same thing as 1 gallon of gas. And I know that usually the dollar sign goes in front of the number, but all of our other units, the dollar sign, or the symbol comes after it, and so I'm just doing this for consistency. I could write that 1 trip is the same thing as 22 miles, or I could say that 22 miles is the same thing as 1 trip. Finally, I could say for this last one right here that 25 miles is the same thing as 1 gallon of gas, or that 1 gallon of gas is the same thing as 25 miles. So I'm going to use one of each of these 4. And notice that it's okay, measurement, estimate, measurement. I don't have any facts on here. These are all going to be roughly accurate. None of these are going to be perfect, and that's okay. So I'm going to have to figure out which of these 4 I'm going to use. So maybe, and I'm just guessing right now, maybe I'm going to use that one, that one, that one, and that one, or something like that. But setting the problem up, seeing what it's asking for, just like we did up here where I knew I had to end with slices on top, is going to give us a big hint. And it's asking me how much it will cost, the money, each week. Each implies that I'm going to be dividing, or money per week. And so I know I'm going to wind up ending in dollars per week. And so I know, looking up here, that I'm going to need to pick the fraction that has dollars on top. And there's only one of them. It's that. So I can cross that bad boy out. I also know that I've got weeks on the bottom down here. So I'm going to be looking for the one that has week on the bottom, which is that one. So I can cross that out. So I'm going to start by setting these 2 up, and I know that I'll have 2 knowns, and I'll have 2 that I don't know, but I'm going to have to take these 4 measurements and estimates and somehow combine them all. Oh, good job, Notability. Snap that straight line to leave me with only dollars on top and only weeks on the bottom. So I know that I have 2 trips in 1 week, and I know that I have $3 is the same thing as 1 gallon. Well, the dollars on top is fine, and the weeks on the bottom is fine, but I need to get rid of this gallons. This gallon right here doesn't belong. And so I've got to come over here and find one of my 4 fractions that has gallons on the top to cancel that out. And it turns out that it's that one. So I'll cross that one out right there. And it leaves me with 1 gallon over 25 miles. So I can start crossing some of these things off of here. I know that this gallon cancels out that gallon, but I've got trips and weeks and dollars and miles, and that's not good. I need to be left with just dollars over weeks. And there's no trip on this side, all right? The trip doesn't exist over here, which means I need to get rid of that. And the way I'm going to do that is by finding the one that has trip on the bottom, which is this. Oh, what a funny coincidence. It just so happens that all 4 of these that I pick were from the same column. Don't think that that's going to always be the case. It's just a coincidence that it was all 4 of the facts on the right-hand side. So what I'm going to do here then is throw in the number of miles per trip. So 22 miles is the same thing as 1 trip. If we go back and look at all the units that cancel out right now, trips and trips, and miles and miles. All that's left in my answer is dollars on top, weeks on the bottom. dollars on top, weeks on the bottom. This has to be right. Well, maybe not 100% perfect. Remember, this is just an approximation right here. But I feel pretty good about each of these facts right there. I'm confident that they're at least accurate enough. And because the units cancel out correctly, I know that I set it up at least right. So my answer winds up being 2 times 3 times 22 over 1 times 1 times 25 times 1, so over 25. I can't do that in my head. It's going to be, I don't know, probably about 5 something. 2 and 3 times 22 divided by 25. Yeah, this winds up being $5.28 per week. Now, is that perfectly accurate? Of course not. Each of these is going to change from time to time. Maybe I won't go in next Friday. Maybe gas gets more or less expensive based on whatever. Maybe I borrow my wife's car, or maybe I ride my bike or something, or maybe I have to take the long way because there's traffic. Like there's going to be change for all 4 of these. But the important part is that the method is sound. I've got myself a good system here to build this. I've built this model, and if I ever want to go back and tweak it, like if life and death, like it was super important that I got a more accurate number, I can go back and do some work to come up with a better estimate for those numbers right there. At the end of the day, though, I look at this and say, okay, that's a pretty good estimate. I like that. You all are going to do something like this for me. You are going to solve an ungoogleable problem about yourself, and that's coming on Wednesday. But that's about it for now.